In this video, we are continuing with section 11.1. This is about hypothesis testing for population variance sigma squared or population standard deviation sigma. So the hypothesis can be set up in one of these three different ways, like we have seen so many times in the past. So there's a left side one-tailed test, right side one-tailed test, and then two-tailed test. All three are for sigma, and sigma sub 0 is the value of the standard deviation that we want to test about. Or you can express the hypothesis tests in terms of variance also. It doesn't matter which format you choose, both will give you the same result. Now the test statistic is n minus 1 times the sample variance divided by the value of the sigma squared in the hypothesis. So once you compute the test statistic, then we can use these functions for p-value. So if it is a left side one tail, we use chi-squared dot dist. If it is right side one tail, we use chi-squared dot dist dot rt. Yeah, and if it is a dist function, you need to include the comma 1. And for a two-tail test, you compute both these values, the left side and the right side tail, select the minimum of the two, and then you multiply by 2 for two tails. So that would be the p-value for two-tail test. So let's look at the Excel example. We're going to look at the example in page 456. Okay, page 456, the example is about DMV test score. Historically, the variance of the test scores been 100. Now, a new examination has been devised, and the administrator of the DMV, they want to know whether the variance is still the same for the new test as it was previously. So our hypothesis is going to be whether there is sample evidence to show that the variance has changed from what it previously was. The null hypothesis that it is the same as it was previously. So we take a sample of 30 and compute the sample variance. The sample variance turned out to be 162. And based on this, we have to make a conclusion. So n is 30, variance is 162, and we want to test it at an alpha of 0.05. So the population here is DMV test scores for the new test. Sigma squared is the population variance of the test scores for the new test. So n is sample size, and S squared is the sample variance. And we want to test whether the null hypothesis is that it is equal to, and the alternative that is that it is not equal to. (100). So we have sample size of 30, and the sample variance was 162. So the test statistic is given by this formula. So that is n minus 1 times the sample variance divided by the hypothesis value for sigma squared. This is sigma squared. So it's already sigma squared, so there is no need to square it. Degrees of freedom is n minus 1. Now this is a two-tail test, so we have to look up the left side tail and the right side tail. Okay, so there it is. So left side tail is chi-squared dist, a chi-squared value, comma degrees of freedom, comma 1 for the cumulative probability. Now, chi-squared dot dist dot RT will give you the right side tail. Same test statistic and the degrees of freedom. This time you don't need a comma 1. Now the p-value is 2 times the minimum of these two because it is a two-tailed test. So let's so conclusion is since alpha is 5%, since p-value is less than 5%, we reject H above. So that means we have sufficient sample evidence to conclude that the variance of test scores for the new test is not the same as 100. The probability that this conclusion is wrong is 3.7%. We look at one more hypothesis test example in the next video.